the microscope. Okay, welcome back on my channel. We will continue with the microscope. A simple magnifier or microscope is covering lens of the small focal length. In order to use, we will see in the next page figures. In order to the use such a lens as a measure a microscope, the lens is held near the object, one focal length away of our lens, and the eye is positioned close to the lens on the other side. The idea is to get an erect, magnified, and virtual image of the object at a distance so that it can be viewed comfortably. Okay, that at 25 centimeter or more of the object is at a distance f, the image at infinity. However, if the object is at a distance slightly less, and this is the figure, one by one we will see. This is the first figure, okay, and this is the second figure, okay. In first figure we can see eye focused on near point, eye focus on near point, see carefully, and the second one is eye focused at infinity. Yeah, both figure are different to each other. Okay, the next one we will see the focal length of the lens. The image is virtual and closer than infinity, although the closest comfortable distance for viewing the image is when it is at the near point, okay, at least 25 centimeter. It causes some strain on the eye. Therefore, the image formed at infinity of upon considered most suitable for the viewing by the relaxed eye. Okay, we saw the so both cases. The first one is this one and second one is another figure. See, two figure are given. So next one, the linear magnification M for the image formed at the near point D by the simple microscope can be used by using the relation. So we will see the next one is M equal to V upon U, where equal to V into 1 upon V minus 1 upon F, and when we will solve it, it will become 1 minus 1 upon V upon F. Now, according to the our sign convention, V is negative and is equal in magnitude to D. Thus, the magnification is M is equal to 1 upon 1 plus D upon F, and it is also equation. Since T is about 25 centimeter, to have a magnification of 6, one needs a convex lens of the focal length f is equal to 5 centimeter. Note, M is equal to h dash upon h, where h is the size of the object and h dash is the size of the image. This is also the ratio of the angle of subtended by the image to that subtended by the object. It, if placed at D for comfortable viewing, okay, note, it is not the angle actually subtended by the object at the eye, which is h upon u. And so next one is, and less simple magnifiers achieved at that it allows the object to be brought closer to eye by eye than D. Continue. You will now find the magnification when image is at infinity. In this case, we will have to obtain a angular magnification. Suppose the object has a height h, the maximum angle it can be also obtained and be clearly visible without lens is when it is at the near point distance d. The angle subtended then is given by delta theta 0 is equal to h upon d equal to approx to the delta 0 theta 0. We now find the angle subtended at the eye by the image when object is at u from the relation h dash upon h m equal to v upon u. We have angle subtended by image. So tan theta 1 theta I minus h dash upon v equal to h upon minus u, and it will cancel, so it will become theta. The angle subtended by the object when it is at u is equal to minus f. Theta is equal to h upon f, as clear from the angular magnification is therefore m is equal to theta I upon theta 0, which is d upon f. Is it? This is one lens. Then the magnification when the image is at the near point, but the viewing is more comfortable. The difference in magnification is usually small. Its subsequently discussion of the optical instrument, microscope, telescope, we will assume the image to be infinity. Okay, so this is the figure. Okay, this is a dash double dash b dash at infinity. Okay, and we know that this is the u and this is the f0, this is fe, and this is the I, and this is the object. Okay, so next one is